use a framework if you can, because it's going to implement things that are best practice. Something that a lot of people don't realize is with sessions, you don't want to create a session when the user first hits your site. You don't want to generate a session token for them, and then they go and they log in and they keep using that same session. The reason is because then you're susceptible to what's known as a session fixation attack. And what that allows the attacker to do is they go visit your site, they get this session ID, and then they can put it in the URL. They can craft a URL that passes it in, and then say, hey, go check out this site. And then this user goes to the site, and now they have that session ID, and then if they register for the site or they sign in, they're a user of the site. Then when they go to use the site uses the same session ID. And now you've got the situation where this attacker knows their session ID and can become them once they've logged in. Again, that's one of the reasons why you don't want to assign them a session ID until they've logged in. You want to always make sure your sessions time out something short like 15 minutes. Less if you can get away with it, a little more if you can't. You don't want a session to last more than an hour. The reason is because you might have in a Wi-Fi spot, there's, if someone grabs a whole bunch of session tokens, it might be a while before they get around to actually trying them out to see if they work. And if the user, if the session only lasts for 15 minutes and the user kind of walks away, hops on a bus, then that session will time out and it won't be valid anymore. So it's just good practice to keep it down low. 15 minutes is about the average. You always want to make sure you provide some way for the user to log out. It's not so important when you carry around your laptop. It's a lot more important when you are using the library computer, and there's going to be another user that's going to come up after you, and you want to make sure that your users are able, or in that situation, are able to make their session token invalid. You also want to create new session tokens whenever the user goes to the sign-in page. So you should assume that if a user is at your sign-in page for your application, that they must think that they're either logged out or it's a new user, and you just end their session if they have one, and then you force them to log in. They're at the login page anyway, so they're going to log in no matter what. So just end any session that's there. That just, it's a good safety practice, especially in the situation like a library where someone comes up afterwards. Brute force attacks, you definitely want to prevent. We talked about that earlier. You definitely want to make sure that your system deals with it in some manner. I just want to point out that if you lock out the account after so many tries, say they try 10 times, and then you lock the account out and then it has to be an administrator that unlocks it, that provides an attacker a new attack, which is rather than trying to get in as that user, now they can lock out all your users, especially if they can enumerate lots of usernames, because then they just try 10 times with each user, and suddenly they've shut, your competitor shut down your entire e-commerce site. None of your users can get in. So you don't want to, it's a double-edged sword. You don't want to allow, willy-nilly brute forcing, but you also don't want to allow them to lock everybody out of the system. You definitely don't want to allow them to lock up your administrator username and password, because then you won't be able to get in, which is another reason why you should have a separate application. And if you can, it's, always have everything come over HTTPS. It's just because then it doesn't matter if they're in a public Wi-Fi spot. If it's over HTTPS, at least it prevents eavesdropping. You don't have to worry about usernames and passwords and the like being exposed. All right, how are we doing? How am I doing on time? I don't. Okay.
No one cares.
All right. So interpreters with web applications, there's a lot of interpreters that you end up coming in contact with your application. The browser is an interpreter. It takes HTML and renders it into some sort of visual. MySQL is an interpreter. It takes SQL commands and renders that, returns back requests. LDAP and XML, OSI. These are all injection attacks. The OS commanding down there at the bottom, that's where you use the command line stuff that Peter was talking about. So you want to make sure that no matter what interpreter you're sending data to, that you've always protected that particular data. So if you're sending data to the browser, you want to make sure that you've either done encode HTML. It depends where in the HTML it appears, but encode HTML is the typical one. You send SQL commands, not so much for classic inlines, obviously Lasso takes care of it, but for SQL inlines, you have to make sure you use encode SQL or cast it to an integer if it's an integer. And in general, you always want to use an API instead of directly using the commands, like on the command line. By using an API, it can then wrap all that extra validation and sanitation so that you don't have to think about it. You can just use it and know that you're safe. For XSS, they talk about doing input validation, output coding, but I'm going to skip past this. I covered it last year, and I know we're short on time. Crypto. How much more time do I have, actually?
About 1 hour and 10 minutes.
All right. We'll go over. I'm going to talk about encryption tomorrow, but this was in their presentation. And kind of just, well, I'll just go through it. Cryptography, really, it's on the surface seems really, really simple. The more you read about it, the more scared you get, and then you don't want to use it at all because you're so scared you're going to get it wrong. The thing about encryption is that there's a lot of nuances. You know, the bit size of the key and the block that you use for the cipher, and it all adds up to be disaster. If you choose anything that goes wrong, anything that's misstepped, will render the encryption worthless, more or less, except for the casual person who doesn't know anything about encryption. So you definitely want to make sure that you choose the right settings. And again, I'll talk more about that tomorrow. But so cryptography, you use it for authentication. You can use it for public-private keys is one example of that. Non-repudiation, that's where the person says, "Oh, I didn't do that." And by using strong encryption, you can actually prove that they did do it. Confidentiality and integrity, that's only the person who's supposed to see it sees it, and the message hasn't been changed between you and the other party. And then encryption, there's 3 algorithms. There's symmetric is where you use the same password to encrypt it as you do to decrypt it. Asymmetric is a public and private key. The public key you can use to encrypt something, and then the private key is the only one that can decrypt it. So that's great for unsecured channels where you want to send a secret message to someone. They'll send you the public key, which anybody can have, and then you'll send them back this encrypted message, and only the private key can unencrypt it. And hashes are one-way. They're designed such that you have some message, you pass it through this hash function, and it comes up with some relatively unique value. Don't confuse it with encoding. It's obviously not coding. Don't write your own ciphers. Don't think you're some super sleuth hacker and take blowfish and make bluefish or something. Just don't even try. This is some minimums that were suggested for bit sizes. Again, it's just if you choose less, it's weaker and can be brute force. So really important when you're implementing encryption is you have to allow for new algorithms and hashes. So, and the reason you have to do that is for a couple things. One, and new keys and new passwords. Because one, if your password is compromised through some manner, you have to be able to change it. Algorithms are constantly broken, so they become weak. Or the bit size you've chosen has become weaker because the computing power has gotten stronger. So guaranteed in the future, I can guarantee you whatever encryption you choose to use, you won't be using that 2-3 years from now. You'll be using something that's a little stronger and something that's a little stronger. That's all you can do in cryptography. And obviously keep your passwords protected.